Hello again, class. We are back for 13.7 Inequalities in Two Triangles, and this is our last lesson for Chapter 13. Yay! So, we start out with our essential understanding, which starts with one of the most famous theorems dealing with triangles. We nickname it our Hinge Theorem. We'll talk about why in a second. So when we think about a door, think about opening and closing a door, and think about the hinges. The hinges are always right here vertically on the edge of the door. Now that door, between the frame, the door itself, and the opening of the door, make a triangle. So the further you open the door, the larger the distance between the door, the larger the angle that the hinge creates. This deals with our side-angle-side inequality theorem, which tells me that if I have two triangles that are related to each other, and I know congruent parts, but then I know parts that are not congruent, I can figure things out based off comparing those non-congruent parts. Let's look a little bit more at this. So here is our hinge theorem. We know that AB and AC are congruent to YX and XZ, so we have two pairs of congruent sides. So if these angles between them, if the included angles were congruent, we know we'd have congruent triangles. But what we see is that angle A is greater than angle X. So angle A is your included angle here, X is your included angle there. And that then tells me, because A is larger than X, that BC, the side corresponding to that angle, must be larger than X, or must be larger than YZ, the side that corresponds to angle X. Please make sure that you've worked through problem 1 to make it to this got it. So when we talk about what inequality relates LN and OQ, well, LN and OQ are the sides opposite my angles. So again, we want to look at which angle is larger. So we have 125 degrees would relate with that side. My 78 degrees would relate with that side. So we could then say that LN is greater than OQ. Now for B, we'll get to how we use the indirect reasoning here in just a second, but first let's just look at what we know. We know that AB is 3 and CA is 6, PQ is 3, and RP is 6, so here we have my congruent sides. So the sides that are not congruent are BC and QR. Now what I see is that QR is 5, BC is 4, so since QR relates to angle P, and BC relates to angle A, that tells me that angle P is going to be larger than angle A. Now I'm asked how to prove this by indirect reasoning. Remember, indirect reasoning starts with taking the contrary of what you're trying to prove. So let's look at that. And you can read through our paragraph proof here to see how when I temporarily assume that PQ, or measure of P, is not greater than the measure of A, that both of those situations create a contradiction. Them being equal would give us congruent triangles, which is a contradiction, and them angle P being smaller than angle A also gives us a contradiction. Try number 1 and 2. Come back when you've got your answers. I've already highlighted a little bit to help you in number 1. See what you can figure out to relate these different segments. So we first start by looking at my supplementary angle pair here, and since I have 82 degrees on this side, I would need 98 degrees on this side to make the supplement. 98 degrees is funny if you know the band from way back before you guys were alive. So then we know that 98 degrees relates to my side over here, and then my 82 degrees relates to my side right over there. So my larger angle will give me the larger side, so I can then conclude that KL is going to be larger than LM. Now you must remember that the hinge theorem is really the nickname for the side-angle-side comparison theorem. So we would have to have the included angle. So here we have a side and the included angle. Here we have a side and a not included angle. Since I don't know what angle V is, I can't figure out what angle W is, and therefore I don't have enough information to solve this problem. So there are your answers. Please make sure you've worked through the next section in Pearson until you get to the got it problem involving the scissors. Come back when you're ready and have your answer. So our think is asking us what does not change in this problem. Well, these lengths of the scissor pieces will be the same for both of them because you can't change the lengths of the scissors cutting surfaces. What you can change is the distance between them. So when we try to relate the distance here when we have 35 degrees to the distance here when we have 40 degrees, the hinge theorem tells me that if I have a larger opening at the hinge, that the distance between the points will be larger, so therefore this distance is greater. And there's your written answer if you prefer that. Go ahead and think about this robotic arm. Same type of problem, we want to use the hinge theorem to justify in which position is the tip of the robotic arm closer to the base. Just like in our last problem, because the length of the robotic arm pieces will not change, what we see is the opening that has a 60-degree angle at the hinge of the robotic arm will be larger than the opening with a 40-degree angle at the hinge of the robotic arm. And if you like the written response, that is right here. Like any good theorem that we have, the converse of the hinge theorem is also true. So what the converse tells me is now instead of relating the angles to the sides, we relate the sides to the angles. So if BC is larger than YZ, then angle A would be larger than angle F. Alright, so now I've got that all color-coded nice for you. Now if you want to know the proof of this is not in your notes, but it's nice to look at. So here's our indirect proof of the converse of the hinge theorem. So what we have, we start out with knowing our two pairs of congruent sides. So AB is congruent to XY, AC is congruent to XZ, and BC is greater than YZ. Of course, we know this span, we know our side BC being larger than YZ. So, again, we assume temporarily the inverse or converse, the opposite, the negation of what we want to prove. So we negate A being greater than X. So we assume temporarily that A is not greater than X. Therefore, A would either be less than or equal. We then work through both of those situations. If measure of angle A was less than X, this creates a contradiction because of BC being greater than YZ. Then if I set them equal to each other, this creates a contradiction because that would make their sides opposite equal to each other, which contradicts another part of the given that we're told, and therefore this cannot happen. So we've contradicted both of our other options, proving that measure of angle A must be larger than the measure of angle X. Make sure you've worked through the next part of the Pearson lesson until you get to this got it. Go ahead, pause the video, try it on your own, and then come back when you think you have the possible values for X. Alright, if you didn't work through the Pearson module yet, this is going to be very hard to begin with. So we need to separately find our upper and our lower limits, and we do this with two different inequalities. To find our upper limit, we start by saying, hey, you know this 90-degree angle, which relates to this side, which is 9? Yeah, that's going to be bigger than this angle, 3x plus 18, since it only relates to a side of 7. We know based on the hinge theorem, this angle will be smaller than angle N over here. So we then use algebra to solve. We subtract 18 from both sides, and then I divide by 3 and find that my upper limit is 24. That does not mean that 24 will actually work. That just means it's the upper limit of my range. To find my lower limit, I say, hey, you know this angle? It's an angle. It exists, so it must be greater than 0. Then we use the algebra to solve, subtract 18 from both sides. This does seem a little nonsensical, but when we divide by 3, we get that our value for x must be greater than -6, which would give it a positive value when we plug it back in here for the entire expression for the angle. That then, when we combine both of these inequalities together, I get that my final answer is the range from -6 up to 24. Alright, I'm really trusting you guys here to pause the video and try 4 and 5 on your own. These are hard skills, so if you do not try this on your own, you're not going to be ready for the test. So pause the video, come back when you're ready to see the solution process. Alright, let's look at finding the limits for number 4. So we know that we relate the two sides based off the hinge theorem. So 6 is going to be bigger than 5, so therefore 36 is going to be bigger than the 2x minus 12. So my two inequalities that I create is 2x minus 12 has to have a positive value, so it's bigger than 0. And then this angle, 2x minus 12, will be less than 36 based on our hinge theorem. I work through the algebra, and then I find that x must be greater than 6, and x must be less than 12. Therefore, I can say that the range for my x value is between 6 and, oh, I have an error. Ooh, here's my error right here. Instead of adding 12, I accidentally subtracted. So this should have been 48, and this would have been 24. Everybody makes mistakes. My apologies for that right there. When we look through number 5, we see that the inequalities that I create are the 4x minus 10 is less than 50 because my 50 corresponds with the length of 15. It's longer, therefore the angle is bigger. My 4x minus 10 also has to have a positive value, so it is larger than 0. From there, I can use the algebra to solve, and I did it correctly on this side. I again use the algebra to solve, And that gives me my range for number 5 to be between 2.5 and 15. All right, pause the video, make sure that you've worked through the next part of the lesson in Pearson until you make it to this got it, and try to solve it completely on your own. We need to write a proof showing that LM is greater than MN. All right, so here's our proof written out. You can check out, I will explain it really quickly too. What we see is we have a shared side here, OM. You always want to use your reflexive property to relate a shared side in triangles. And then since O is the midpoint of LN, that tells me that O to L and O to N are also congruent lengths. Then because I knew that angle MON was 80, I can solve because the supplement that MOL is 100. And then based off the Hinge theorem, we know that LM will be greater than MN because we had side, angle, side, and the Hinge theorem tells me if the larger the angle, the larger the side. Because we want to keep practicing writing our proofs, go ahead and pause the video, try to fill in everything in this proof here. You've either been given the statement or the reason. You need to find the missing part that corresponds. All right, guys, so we start out here. Relating measure of angle EAC is equal to the measure of angle AEC because that's some given information for us. So we go ahead and highlight that. So it's this angle here at A and this angle here at E. Now those relate to the sides opposite them. So E relates to side AC and A relates to side CE. And because they're related and they're congruent, we can then say that EC is equal to AC based off the converse of our isosceles triangle theorem. When we have an isosceles triangle or congruent angles at the base, we know their corresponding sides are congruent. Now C being the midpoint of BD, that is just more given information. But then because C is the midpoint, I can say BC is congruent to CD because that's what a midpoint is. It tells me that it breaks the line into two congruent segments. Then congruent segments must have equal lengths. That is just stating that the segments were congruent. Now I can say they're equal. Then we look at the measure of BCA. That BCA is greater than DCE, and that is more given information. So I've highlighted that up here, BCA compared to DCE. And then I can actually say that AB is greater than ED based off our Hinge theorem because I have these congruent sides here. I know that BC is congruent to CD, and I have these interior angles, or the included angles, relating the side lengths, which lets me prove what I was out to prove. Pause the video and try number 7 and 8 on your own. Come back when you're ready and have your answers. Because I have my two pairs of congruent sides and then I have the included angle to compare, I know based on my Hinge theorem that FD will be larger than BC. The big thing to look at in number 8 is that ST is a shared side between my triangles. So because of that and knowing that SU is congruent to SV, I now can use the Hinge theorem to relate these included angles UST and VST. Well, VST relates to 12. UST relates to 14, so we say that UST will be the larger of the two, and there are your answers for 7 and 8. That is all that I have for you guys in this lesson, so please make sure that everything from Chapter 13 makes sense. Let me know if there's anything at all that still confuses you, and I will see you guys in class for the test. Have a wonderful day.